Hello everybody, this is the low level designer. We are making a compiler from scratch. We will implement the scanner today. Before we dive in, we have to restructure our project a bit. Like this main file is getting big and it will get bigger if we don't restructure it. So I like to keep my project simple with just a make file. If you don't know make file, I will just explain it. So like every C project, there will be two folders in our project. That will be source and other will be include. Okay, so a C project is structured in a way like the function signatures resides in the include folder. From that you can know what is there in the code base and the all over map of this project, and also you get help from the autocompletes and also what function is there in the project. And in the source folder, src, the source folder, there are the implementations. We implement the functions. So the functions here, they're included already here, because and there is no error because the main function is at last. We call every other function and the compiler knows the function signature also. Signature means how the function looks, what it returns and what it accepts. That is called the signature of that function. So the compiler knows all the function signatures and also its implementations. So the compiler doesn't need to know what the implementations are. That's why we segregate it into two folders. But let's just make a folder. And also I have named this project Jarvis. So not J, it is Z. So we are making a compiler. I'm a fan of Marvel, so Jarvis is a very good like language processing model, maybe NLP. So we should. I named it Jarvis. You can name it whatever you want. So okay. So in the Jarvis folder, we will make a new file that will be din_array.h. That is dynamic array.h. And inside this, we will shift all the dynamic array structures and the signatures, function signatures that acts on the structures. So that is this integer array. Let's cut it and paste it here. Also, before all the header files, you have to put some include guards, because the compiler may include that file twice, so that we here write pragma once. The compiler doesn't include it twice or so pragma once is supported in all the modern compilers, so we don't have to worry about its compatibility. Okay, so this is the integer array. It is the byte array. And also the float array. Where is the float? Yeah, the float array. Okay, so the structures are here. Now we have to write the function signatures. So let's just copy this whole thing, this integer array functions. Let's just cut it. In the source folder, let's make a file dynamic array.c. Here we will put the implementations. First, we have to include the dynamic header file so that it knows what the structures are. So include. Okay, so in the VS Code, to know that the include files are in here, we have to make also in the .vs file so that we get the intelligence. That is c cpp properties.json. Okay, so here it just takes an object that is a configuration and we name it, and it takes an array of object. Name, it will be Linux, as I am working on Linux. The C standard will be C99, and also I guess it filled up the all the things, and also we have to include the folder of include files, so that will be include. Okay, that's fine. Now when we say this angle bracket and Jarvis, it will get the auto completion. Fine. Okay, these are the still unidentified. We will handle it shortly. Okay, and a lot of things to do today. We will make the scanner from scratch. So okay, so let's make a common .h that will be included in every header file. We will just take these that will be included in more or less every header files, and we will paste it here so that we will get these on every files, and we get the autocompletes. It doesn't give us error. Okay, now we in the header file we will include the common.h. Now see, the errors are gone. Okay, the integer array, so let's take this, copy it and paste it here, and just remove the implementations. We just need the signatures. Okay, just make it pretty. Okay, the integer array functions are here. Let's do the same for float array. Let's cut it, paste it here, and also paste it in the header files and delete the implementations. Nice, and also for the byte array. Seems I can't select. Cut it, paste it after the float array part. Also paste it in the header file after the byte array struct, and same drill. pretty. So if you follow last two streams, I follow a very simple protocol when coding. C is just some data and the some functions that act on it. So I like to keep the data structure and the related methods together, so I can find everything nice and the naming convention, you can guess the action is on the first uh, block of that word, and the data it acts upon, it's the second block of the word. So init int array means it will initialize that int array. Print int array means it will print the int array. Add, same thing. Okay, fine. And now that we are a bit advanced, and we should say, so let's make it not add, let's make it append, so that it relays the, like, it conveys the action what it's doing. So append and delete makes remove at. Same thing, append and also this remove at. We're not using the remove at this moment, but we will. And this remove at, if you follow the string, this remove at just swaps with the last element. So it is not safe if the order is important for you. If the order is important for you, then you should write another remove function that maintains that order, and it will be O n time. How many elements are there in the array? The time will depend on it. Same thing, append and we will apply it, remove it. And also in the last stream there was a bug in the, where is it, the main file. Okay, so the bug was in the virtual machine. After each case, in the switch case block, we have to put break. If you remember, we were getting a operation sub, so after addition it was not breaking, it was going to the sub, it was falling through. So we don't want that, we have to break it. So if you followed it, you have to just put break after each case if you want it to break the switch block. Okay, so now let's move on. Let's make another file, stack.h. All the stack related function will be here, and also stack.c. Here the implementation will be there. Okay, so in the main file, let's take this, cut it, put it in the, include the header guard, and paste it. It can't recognize the float array, so we have to include the dynamic array header file. See how easy is that? Now we have to let's take it to the stack.c. Let's include stack.h. And it's good. And we also have to give the signature. So let's just delete the implementations. Same drill. Stacks looking good. We have only now float stack that can hold float values. Afterwards, we can implement the other data types. So I'll just delete this. Okay, let's make a vm.h, that is the virtual machine, and also vm.c. Let's take all of this and paste it to the vm.h file. We have to include guard. We have to include the dynamic array. Fine. Okay, so let's close all these things. Okay, the machine also will go there. We have to include the stack part. Nice. And okay, now the code chunk functions, let's take it there, cut it, paste it. Let's include the vim.h file. Hello Aditya Singh, how are you? Okay. Nice. So let's move on. And also vim.c, we are good. Let's copy this and also put this in the vim.h file after the machine. No, it is function for the code chunk, so we will put it here and just delete the implementations. So for those who joined late, we are just restructuring a project. We haven't implemented the scanner yet. We haven't started. We will shortly. We are restructuring a project for some small to mid-sized project. We will use makefile. That's why we are restructuring it. Let's delete it. And okay, the code chunk function, and let's delete this part. Fine. Now let's shift the machine functions. Okay, the whole thing is gonna go to the vm.c file, and also we will demarcate it with the machine because it accepts the machine. Execute the machine, And okay, I guess let's take this and take it to the header file, the machine part, and delete the implementations. Okay, so this check error function, we not need to expose it to the header files. That is some internal function we just written for our help. Okay, so the VM part is done. Now in the main file, we include vm.h. Okay. All is gone, I guess. Okay. Let's take the main.c file, also put it in the source. In the main file, there will be only the main function. Keep it simple and keep it readable. Okay. So now that we segregated our project into two parts, include and source, we have to take help from a build system, and we will use make. For make, we have to use a make file. So let's create it. The name have to be exactly like make file. You can make the aim small, but I like to make aim big, but it has to be make file. The name has to be make file. Okay. In the make file, we describe our project dependencies. Like to build stuff, what you have to build before that. So we write it in a syntactical way so that the make program know how to build your project. So to build our project, we have to just compile all these C files together and make the executable. Because in the main.c file, the main function is there, so there will not be a problem for an executable. Okay. So let's make the make file. In the make file, I like to keep it very simple. Let's make a variable source directory. Okay, so for Windows guy, you have to download min.gw or anything like that to access all this stuff, GCC and make. In the min.gw, I think that make program is named as min.gw32-make. You just copy it and rename it to the make, so you can use the same command as mine. I just type make something and it just works. Okay. And in the Linux, the make is already there if you have the build essentials. Okay, so source directory, it is /src /min, it is on the same folder. Okay, we have to give the include directory, that is include. If you don't give the compiler this include directory, we can't use this angle brackets. These angle brackets we only can use if we provide the include paths in the make file. If we don't give it to the compiler, we can also write it like this in the double quotation, and we have to give the relative path, that will be // because the main.c file is in the source folder. If we type .. it goes up one level. There it has include and there Jarvis folder is there. So the header file we can access it like this, but we don't want to write this every time we include, so we will just give this header file. Now we will make some temporary directory for the object file it generates. We can we may also omit it. Let's just omit it for now, and we have to give it the target name. So the target name will be Jarvis. Okay. Now we have to make the CC variable. CC means C compiler. We can make it GCC, or also we can make it CLang. So I like to use GCC. So let's just make this GCC, and also the C flags. In the C flags, we have to provide the flags we have to give the compiler. That is the output name. No, the output name will be target, but the additional things they include the error detection. So let's just write it. That is the WAL. It will report all errors, not errors, warning, and also WAR. It will like the warning will be errors. So you can't compile unless you check all the warnings. And also -G, that is for the debug symbols, and we have to give the include directory here. Okay. Now let's just make. Now we have to collect all the C files that are present in the source folder. So that we are collecting it in the src variable. How do we do it? We use the wildcard function that is provided in the makefile. Wildcard so what it will do in the source directory, whatever the file name is, it matches with star means anything it can be there. So whatever matches with star anything.c, it will collect. Okay. So the sources are collected. Now the interesting thing, we have to tell the make how do we build our project. So the first, this is called a target. First target, it always, if we type just make, it will build this all. So this all depends on what target. And the target depends on this source files. So let's just make it. That is the and also we have to write the obj. Okay, so for the obj variable, we can do a pattern substitution. Like we have collected all the source files into the src variable. We will just take those entries. We will substitute whatever is before that dot c with that dot o. So for that, we have also inbuilt function that is pat subst, that is for pattern substitution, and same thing. It takes the input pattern, then the output pattern, so let's just make that temporary directory. And we will make it star dot o, and it is the input. Okay. So our target depends on these object files. So how to create the target? So we provide our C flags. This will just run as a command. CC means GCC. So GCC, the C flags, GCC after GCC, this will be put, and also then we give the input. That is this symbol. This symbol means all these object files. So this symbol is, so there are some built-in symbols. There are this means just the first one. This object file is just a list of entries. We will take just the first one, and if we make it this, it takes all of those entries. Okay, and we also state the output, and that will be dollar that. And this is also a built-in thing. This is this thing, this dollar target, that is service. So when it executes, this is gonna look like this: GCC, and after that C flags, and in the include directory it will be put this, and also this object file will be dynamic array.o main, and that will be generated automatically. Make can do that. If it gets any C file, it will just generate automatically the object files. Okay, so this is our simple make file. Let's see if it works. Main.c. So let's just make it. Okay. Execute. Implicit declaration of execute. Okay, we have to change the function names. Execute machine, and I guess it's fine. Okay, what is it? VM.c 123. Okay, here also execute machine. Okay, fine. Now we will just delete this. Our project structuring is done. Now we will just dive into the schema part. Okay. So for that, I just want to take command line arguments into action. So let's just do it. Okay. If argc double equal to 1, argc is whatever we give the command line argument, argc is the count of the arguments, like how many arguments we have given to the command line, and there is always one argument that is the program name we are running. So if argc double equal to 1, that means only program has been given, and we will go into REPL mode. And REPL full form is read, evaluate, print, and loop. That is, it just goes on, like if you have used Python and anything, if you just write Python, it goes into an interactive mode. So that is the just. And we will, okay, let's just make a machine. Init the machine. Init machine. And in replay machine, we have to just provide the pointer to that machine. Okay. If args is equal to 1, that is only the program name, we will go into replay mode. So let's just test it. Make it makes fine, and let's see it gone into replay mode. I type whatever, it just fine. The replay is working. Now if the args is 2, else if that means file name has been given. It will just there are just two modes. Like it can go into an interactive mode, triple mode, or it can take input a file and it will execute it. So there is no other options or anything. Keep it simple. So if args is 2, we will just pass it to the run file machine, and we haven't written this function yet. We've written it. And run file machine, we will provide the machine pointer, also that argument. It will be 1, because if we arg v0 is the program itself, the name itself, and 1 is the argument. Okay. And if it is anything else, we just write an error message. And just exit. Okay, what is the problem? Missing closing port. Okay. And we return 0 at the last in main file, and if it is else, return -1. Let's just test it. We have an written run file machine. Let's just make it for just placeholder, the vm.h in the machine. So okay, void run file machine. We take a machine pointer, and a file name, that will be okay. That will be a car star file name. Let's make it constant so that okay. And implement it. For now, we will just print the file name. Okay. In the vm.c replay machine, after that we will write the run file machine. Okay. Takes a pointer and also the file name, that is constant character pointer. And for now, just print the file name. And also give it a new line. Okay. errors, I guess. So let's run it. And let's read, let's write a temporary example dot jv. This will be our program extension jv for Jarvis. So here we can write anything like, let's say var a equal to 20, var b equal to 40, print a plus b. So it should give us the file name. It's working fine. Okay, so now let's just dive into the scanner part. Okay. How are we gonna approach this problem? So let's first understand the problem. Okay, so in the scanner it will be a structure, and what will be its job? So let's just take a string. So let's say there is a file. Let's just delete all these things. Print a plus b. So ideally we should give the scanner the pointer to this string, the first pointer, the length, that is the start and the length, and this is the initialization part of the scanner. And then after every time we call next token or next token on that scanner, it should give us a token. And what will be token? The token has a type and a value. Okay, so let's see here what are the tokens. This print, it will be an inbuilt function. So the token of this will be token print, and its value, that doesn't matter, because token print, the value will be always print. Okay, so in the token we need the starting point and the length of it, the token. Then there is a white space, we will ignore it, the white space. Then there is a, and what is a? This is an identifier. So we will get here token identifier, and its value will be a. Then we will get a plus. This is also a token. It is token plus, and value doesn't matter because it will be always plus, because token plus is a different type. The value is already embedded in the type. We know if it is token plus, the value will be plus. So there is no need to give plus. And then we will get b. It is also an identifier. And just the difference between these two tokens, they are both token identifier. But the difference is the value of this token will be a, and value of this token will be b. So this is the job of that scanner. Given a string, given a character string, it will give us tokens. Like if we call the next token every time, it should give the next token. It should give the next token. So for example, if we call next token on this line, first it will give us token print. then it will give it it will skip the white space because we will not bother about those white spaces. Then we will get A, so that will be token identifier, and the value of it will be A. Then again we will get the plus. So if we call next token on the scanner, it will give us token plus, and the value is not, it doesn't matter. And again, if we call next token, it should give another token identifier, and that value will be B. So this is the job of the scanner. So this scanner has many names. It is also called Lexical because it does lexical analysis. Lexical means alphabetical, or and it is also called tokenizer because it gives us tokens. Tokenizer. So it's a very dumb mini little program that just takes input the string and gives us back the tokens. And as you can see, we will it's just like a Pac-Man. Like if you have played Pac-Man, it will just engulf all the characters, and then if it finds a match, then it will produce an output. That is okay. So this algorithm, it is called a greedy algorithm. Greedy algorithm because we greedily engulf every character we get. And the scanner we will implement today, that is a look ahead scanner. And how it works, let's just make this simple. So the scanner part has some data, that is the first text, and that is the string part. The string it acts upon, and this string, the scanner is not the owner of that string, that is the memory in the string resides. It just takes the pointer. It is a string, that is it's a pointer to that text. Then it has a current, that is integer. This current always points to the start of a token or a possible token. Then there is a look ahead part, that is also an integer. This look ahead will help us in the peaking part. When the current pointer is here, we will peek some that is called look ahead. We will just peek in front of us. What is there in the future? What we are gonna get in the future? So based on that, we will produce the output, and the current will always point to the starting of a new token, a new possible token. And there is a helper function peek. It will always, when we call peek on the scanner, it just increases the look ahead, and it gives always the next look ahead thing. Let's say there is a print, and we are scanning it. So the current pointer will point to this P. Then if we call peek, first it will give us R. Then we call peek, and the first peek is gonna increase the look ahead by 1. Then next it will give us I, it will give us N, then it will give us T, and so on. So the look ahead scanner is like this. We will always look ahead of us what character we are gonna get, and we will take decision based on those. So let's just begin the implementations. Okay. So before that, we have to allocate not the file we are executing. So this run file machine. So let's just go to vm.c and implement this. So if we give it a file name, we have to load the file in the memory as a character string. So how are we gonna do that? First, we have to open the file on an operating system level. How do we do that? File star fd, that is file descriptor, and we call if open on it. If open, and it just takes the file path, file name, and the second argument is the mode we are gonna open it in. So we are just gonna read the file. We are not going to make any changes to the file for now. So just we will open this in read mode, and we will provide R for read. And this if open function is in the standard IO. We have to include it. So let's just include it in the vm.h. We include the common, because common and std.io. We made that common file because we don't have to include all this again and again. Okay, so that should do the part. Identifier file is unidentified. Okay, so this is all caps. Bad. File fd if open. Okay, so it can fail. Maybe the file is not there or some error happened. So we have to check it. If fd is null, we have to return. Return. Now to allocate sufficient memory for that file, we have to allocate some memories. Okay, so to load the file, we have to allocate some memories. So how are we gonna know that how much memory it takes file, how much memory we do need to load the file? So there is a neat trick you can see. So there is a function called ifseek. Ifseek is like a cursor to that file. We can move it in the file. So ifseek, we are just gonna provide fd and 0. Let's just write the function and I'm gonna explain it. 0 and what was that? Secant. Okay. So what it is doing? So let's say there is a file. There has to straight. Okay. So ifseek. So let's imagine there is a cursor. What ifseek does? Ifseek this moves this cursor. So in the third argument, there can be 3 values: seek start, seek end, and seek what is there? Seek current. So if we seek end and if we provide 0, it will move the cursor to the end and offset it by 0. That is the end. If we provided seek start, seek current, sorry. So it just offset it by 0, and let's say if I make this 5, so it will offset it by 5 bytes. 1, 2, 3, 4, 5 from the current head where it is current. If we call that function again, it will start from here. 1, 2, 3, 4, 5. And here, if we provide seek end and give a positive number like 2, it will just shift backwards. If second argument as 2, it will give 1 2 2 bytes from the last, that is the second last byte. So that is how fc works. So what we are doing, we are seeking to the end of the file, and let's make it 0 so that, okay, and now we will query the position of that cursor. So we get, so that gives us the size of that file. So file size will be, and that function is fl. Fl returns that cursor position. So now we have got the file size. Now let's reset the cursor, and that is rewind. The function is rewind. This is a very neat trick. It is used in various kinds of projects. You can use it. It's very efficient, and we also give it the file descriptor. Okay. Now it is resetted. So the cursor is at the beginning. We can read it from the beginning. Okay. Okay, let's do an error checking. If it read the, okay, so now let's allocate the memory. And we will give it file size that is in bytes. We don't have to multiply it by anything, and we have to cast it in char star. Okay. The memory allocation can fail. We have to check if buffer equal to null. We just return. Okay, so if the FD is null, let's just print an error message so that we can know what is the error. Print if file opening failed. No such file. Okay. And in this memory failure, let's just print memory allocation failed. Memory allocation failed. Not enough memory. This is a very rare error, but it can happen. It may happen. Let's return. Okay. And after reading it, let's just, okay, let's now read. There is a function called fread. What happened? Fread that takes the pointer to the buffer and the step size, that will be character, because we want to read byte by byte, so size of character. The length, that will be file size. We want to read the entire file at once, and the file stream, that is file descriptor. Okay. And what fread returns is bytes read. Okay. Fread returns how many bytes or how many steps it took to read the file, and we will just check it, because bytes read has to be equal to the file size, or else there is an error. We haven't read the whole file. So let's just check it. If bytes read not equal to file size, I just print an error message. File not read properly and bytes read. We will just output the bytes read and also put the new line. Okay, fine. Now after reading, after all this is checked, then we are gonna end that string with /0, or what we can do is make our own string library. Let's do that. Let's put string dot h. We will not use the standard string library that is in the C because it checks the length with the null terminated string. We won't do that because memory is cheap nowadays. We will just carry our length with ourselves. So let's just say string.c. In the string.h, header guard, and let's make a string struct. And the string, they're really just the pointer that will be the start pointer and the length that will be integer. Okay, so a string can be, I mean this pointer can be the owner of that memory that it allocates, or it cannot be. So let's just keep it simple for now, and let's assume that it's not the not the owner of that memory. That means that memory we allocated here, this malloc, we will create a string out of it, but this is the original memory and we will share it through everywhere. Okay, so we won't copy it anywhere or anything. We will scan on this specific pointer, this buffer. We will pass it the buffer. Okay, so the file is loaded, I guess. Okay, so let's just print the file. I don't know if you know if there is a trick in C. Like if we provide a character pointer, we can provide how many width it should print. So we can provide the length, how many character it should print from that pointer. So for that we just have to, normally we would write %s, but we have to write %.*s, and we provide the length and also the pointer to that. It is the buffer. So let's just print it. Let's take it to the right so that we can see. Okay, compiled properly. See, we're printing the bytes. That is fine. Okay, so now let's dive into the scanner. And they include Jarvis. Let's just scanner.h, and in the source, let's say scanner.c. Okay, In the scanner.age, same drill. Track once. Include the common files. Okay. So let's make the scanner struct. Okay. So in the scanner part, there will be a string. So let's just include the string header file that we have just written. Okay. So there will be a text field. There will be int current. There will be int ahead. And also the and we will also track line number. Okay. So we will track also the line number from when we are scanning. If we encounter a new line, we will just increase the line number by 1, so that when there is an error, we can report it to the console or to the user. Okay. So, okay, let's just call the init function. Let's just write the init function, call it scanner, and it takes the scanner pointer. Okay. So in the initialization phase, it will take a string input. Text. Okay. So scanner dot text will be the given text. Scanner current will be 0, because if you remember, the current will always it will be always the starting of a new possible token. So scanner current equal to 0. Scanner look ahead will be also 0. Scanner line will be 1, because it starts from the first line. We will not count it from 0, because line number is started from 1. See, in the VS Code also, the first line is 1, 2, 3, 4. Okay. So the line will be started from 1. Okay. Nice. So this is the implementation. We will not write the implementation here. Just copy it, remove it, and put it in the scanner.c, and include the scanner file, scanner header file. Okay. So we now have to write 2 more functions. Next. Okay. So this next function, next, or let's call it next token, because it be verbose while we can. Next token scanner, it will just return a token. So a token struct, we haven't written it, but we will write it. It will just return a token. So let's just write token. Okay. So what does a token look like? So there is a type, and that will be an enumeration token type. We will write it type, and its value, that will be a string. Okay, so let's define what is token type. Type def enum token type, and here we will just copy and paste some token types that I have prepared. So what is the tokens? You know the usual stuff: parenthesis, left parenthesis, right parenthesis, left brace, right brace, comma, dots, bang. Bang equal, bang means exclamation, equal, identifier, string, and class, print, the usual stuff. Hmm. পড়ে পড়ে দাঁড়াও, পড়ে বলছি দাঁড়াও। Okay, so these are the token types, and also we will write a peek function in the scanner that will return as a character. So these two functions will be the heart of it. We just take this and scanner.c. Next token. Okay, so let's just write the easy one, peek scanner. What will be peek scanner does? What will be its action? Okay, peek scanner just returns um, the look ahead, current plus look ahead. Okay, so just keep it in picked will be scanner dot text scanner dot current plus scanner dot look ahead. Okay, so a big thing. What? Let's analyze it. Okay, so this is the text, this is the string part, and this is the pointer between inside the string. The pointer is that actual character pointer, and we are indexing it, and we will always return what is the look ahead value, and we will add it to the current and just return this. Let's see what it does pictorially. Okay, so let's say this is the string. Okay, so let's say current is pointing here. This is current, and look ahead is also pointing here. When we call peek, it will add L plus 1 to C, that is C plus L plus 1, that is this value. Peak will return this, whatever is in the first position, it will return that. Okay, it will return that. Then let's say we increases the current value to here. Then we again call peak, L will be here. Again call peak, it will return this. And after every peak, the function will increase the look ahead variable. So look ahead will, after the first peak call, the look ahead will be here. Then if we call peak, it will return this and increase it to the here, this L pointer. Okay, so this is the look ahead method. So we are always, and also we will increase the look ahead by 1. I don't use plus plus, I always use plus equal to 1, because plus plus is, I don't use it, I don't know why. I like it plus equal to 1 better. Okay, and we will return the peaked value. That's it. That's the thing only it does. It just peak the value based on look ahead, and it just returns the character. Okay, now next token part. Okay, the stream has been going on for 1 hour, so I just end it here. We will continue it in the next stream. If you want to be notified, you have to subscribe my channel, I guess, and make necessary adjustments if you want to be notified about the next live stream. Okay, so let's just end it here. We will start from this very point in the next stream. Bye bye.